right, so let's finish up section 2.1, same section as yesterday. Yesterday we learned how to convert degrees to radians and radians to degrees. For today, the only thing you really need to know from that section is changing something to radians. Okay, so if we're given something in degrees, we're going to have to change it to radians. And I'll show you why in a little bit. All right, so I'm going to start out with that diagram. Okay, what I've done here is I've basically drawn a circle. I've got two angles inside the circle. Each angle is a different size. It can be any size. And I've used this Greek letter to represent the size of the angle. Okay, it's a letter we use a lot in trig. Okay, kind of like x in algebra. You use x a lot. Anybody know the name of that Greek letter? Circle with that line in the middle. No? That's theta. Okay, so this is the Greek letter theta. Just think of it as a variable. It just represents an angle we don't know. Okay, and the angle theta here makes an arc, and I've labeled that arc S. I drew another angle here, different size. Just called it theta 1 to give it a different name. And it has an arc connected with it. It's called arc S1. Any questions on that diagram? And R, of course, that's just the radius. All right. So one thing that's important to understand is the connection here between the size of the arc and the size of the angle. Maybe just kind of using common sense, what do you think would happen if you double the size of the angle? What would happen to the size of the arc? It would double. Yeah, it's what we call directly proportional. If you make the angle half as big, you'd make the arc half as big. All right, so because the arc size and the angle size are directly proportional to each other, we can set up a proportion. Okay, and that's what we're going to do. We'll set up a proportion, and our goal is to somehow get a formula that will tell us what the length of the arc is. All right, so we're going to come up with a formula that gives us the length of an arc in a circle. All right. But to set up that proportion, we need some kind of starting point. Okay, we need a fact to start with. Okay, kind of like yesterday when I said to you, in 1 foot, there's 12 inches. That's a starting point. Okay, using that fact, you could set up a proportion. In 1 foot, there's 12 inches. In 8 feet, there's how many inches? Well, all we'd have to do is cross multiply. In this case, 12 times 8 tells me how many inches in 8 feet. Well, this is the kind of starting fact that we need. Okay. So yesterday, okay, we said that if this angle was a certain size, this arc would match the size of something else in the circle. Does anybody remember that? If this angle is a certain size, the length of this arc will be the same as something else. Yep? Yes, if you make this angle a certain size, the arc and the radius would be the same. Do you remember what the size of that angle was? That's the key part. Okay, so if you have your notes, take a look back and see what we said here. 1, exactly. Okay, that's a fact that we know, just like this. This is a fact that we know. We can use this fact to figure out anything we want to know about feet and inches. Okay? From yesterday, I taught you guys a fact, okay, that if your angle is equal to 1 radian, then the size of the arc matches the radius. Okay, so suppose that angle equals 1 radian. Then the size of the arc is going to match the radius. Okay, and this is going to be our starting point to set up our proportion. Just like this idea. Okay, same exact idea. Right, so let's set it up. Right, so the size of, let's start with this angle. Okay. Okay, the size of theta 1 compared to the size of S1, and again, I'm going to plug in a second some things I know, is directly proportional to the size of this angle compared to that arc. So theta 1 compared to S1 is exactly the same as theta compared to S. The reason we can do that is because we said they're directly proportional. Make the angle bigger, you make the arc bigger. Make the angle smaller, make the arc smaller. If that wasn't true, we couldn't do this right here. Okay? So that's a proportion. And now let's fill in. Okay? In place of theta 1, get rid of this. In place of theta 1, we're going to fill in 1. And what are we going to plug in place of S1? Yeah, the radius. On the right-hand side, we have nothing to plug in. Just leave it the same. Right, so all we did was take that starting fact that if the angle is 1, we know the radius of the angle. I'm sorry, if we know the angle is 1, we know the arc is the same as the radius. Okay? You've got to have a starting point to figure out other things. Okay? Just like this. If you've got that starting point, you can figure out other things. All right. Now, how do you solve a proportion? What do you normally do? Hey, you can cross multiply. Right, so what we're going to do here is we're just going to cross multiply. Okay. How about Jess? What's S times 1? Yeah, it just stays the same. S equals R times theta. That is the arc length formula. Right, so if you want to find the length of an arc, all you need to know is the radius and the angle. Okay, so that's the arc length formula. Okay, S is the length of your arc. R is your radius. And theta, that is your angle. Okay, is there anything we might want to be careful about, though, with the angle? Think about way back, the very first step. We made this assumption here. We suppose that theta 1 was how much? 1 what? Radian. All right, we built this whole problem based on the fact that this angle was 1 radian. So when we use this formula, we have to make sure our angle is in radians. Okay. In this formula, you could be asked to solve for one of 3 things. They could give you the radius and the angle and say find the arc. They could give you the arc and the radius and say find the angle, okay, and so on. Okay, so it's three different possibilities. I will always give you 2 out of 3 of the letters, and you'll find the third. Okay, any questions on this formula? So this is important for the test. Okay, so let's try to find the length of an arc. Okay, this problem, I kind of wrote the whole thing out. But the key information here is you have an angle of pi over 3 radians and a radius of 4 inches. Find the length of the arc. All right, So if you're more visual, basically what we have is an angle. Pi over 3, that's 60 degrees if you were to convert it. So that might look about like this. You've got a radius of 4 inches. Our goal is to figure out the length of this arc. Right there. All right, so Ben, what am I going to plug in for my radius?
4.
Yeah, radius is 4. Right, so I've got 4. Chris, what am I going to plug in for my angle? Pi divided by 3. What are the units on that? Radian, so we're good to go. We don't need to change it. Okay, and we'll just multiply that out. If you want to think of that as a fraction, so you multiply straight across. 4 times pi gives me 4 pi. 1 times 3 gives me 3. And that's it. That's the length of the arc. I could type that in if I wanted and get a decimal. So if you wanted to know roughly how big it is, 4 times pi, it's about 4.2. Now, what do you think my label should be on that? I just found the length of an arc. Yeah, John? Inches. Okay. Anytime you find the length of an arc or the radius, that's in inches, feet, okay, whatever the units in the problem are. If you're finding an angle, that's in radians. Okay, we wouldn't measure an angle and say the angle is 2 inches. Could be 2 degrees, could be 2 radians, but it's not 2 inches. Any questions on that one? All right. Okay, this one I just drew out the picture rather than writing it out in words. So you've got a circle with an angle of 130 degrees, a radius of 8 feet. Find the length of the arc. Okay, Andy, first thing I want to do is start off with my formula. Okay, what's my formula for the length of an arc?
S equals radius times theta.
Good. S equals radius times theta. Okay, and before I even start doing it, what do we want to be careful about here? Yeah, what do we got to do with this degrees? Convert it. Yeah. If you plug it in the way it is, and you just say, okay, radius is 8, angle's 130, I'm going to do 8 times 130, it's going to be wrong. All right, so we'll convert it. Okay, and Charlie, to convert it, what do I multiply by? Multiply by pi. Good. Divide by 180. Okay, so degrees are gone. In fact, I can divide by 10. That's gone. So my angle is 13 pi over 18. Okay, now I'm ready to plug into the formula. Okay, so the length of the arc, my radius is 8 feet. My angle is 13 pi over 18. And if there's anything here that you can reduce, go ahead and reduce it. How about Nick? Anything I can reduce the top and bottom by?
18,
Yeah.
2.
Yep, divide them by 2. That gives me 4 and 9. Okay, so my final answer, I've got 4 times 13, which is 52, times pi over 9. Okay, John, what's going to be my label on this one?
Feet.
Feet. Good. We found the length of an arc. In this problem, our lengths were measured in feet. So just Just make sure you put that label. Okay. Any questions on that? All right, so that's good for finding S. Okay, let's look at this one and see what they're asking us to find. So they're telling you the arc length is pi over 4, radius is 12. Find the angle. Okay, so Derek, which letter are they asking me to find this time? The S, R, or theta?
The theta.
Yeah, we're going to find the theta. Okay, they're giving us the other two. Dakota, what am I going to fill in for S?
Pi over 4.
Good, there's your arc length, pi over 4. Okay, and Analia for my radius?
Pi over 12 centimeters.
Yeah, we'll plug in the 12 centimeters. Okay, radius is 12. Okay, good. Times theta. Okay, now our goal is to get theta by itself, so we've got 12 times theta. Natalie, how do we get rid of multiplying by 12?
Divided.
Yeah. By how much?
12.
That's it. Just divide by 12. Okay, dividing this other side by 12 is just like putting a times 12 in the bottom. Divide by 12. Okay, 12s are gone. And my angle is pi over 48. Okay, what's the label on that angle? Well, this formula always gives you your angle in a certain unit. This is radians, okay? Do I need to write radians? No. It's pi over 48 radians. That's all you got to do. Done. Okay, now on the test, I am going to give you some problems that are multiple choice. Okay, there's probably going to be one where all the multiple choice answers are in degrees. So if you had this as your answer, what would your last step be? Convert it. Okay, you'd have to convert that to a degree if that's the way I listed the answer in the multiple choice question. So if I wanted to convert it, it's 3.75 degrees. Okay. The reason I might do that is because then I can test you on converting something to degrees and finding length of an arc in the same problem.
Will you tell us to convert, or do we have to figure it out?
The only way you'll know is when you look at the test. Let's see the answers, and they'll all be listed like this. They'll all have the degree symbol. So you have to remember, your answer is a radian, my answer is a degrees. Okay, any other questions on that one? All right, let's do one more with this. So we've done finding the angle, we found the arc. Let's find the radius. Okay, Tiffany, what is my radius here?
Your radius is R.
Perfect. Radius is R. We don't know. Okay, that's what we're finding. Jake, what's my arc length?
13 feet.
Good, 13 feet. So I'm going to fill in 13 for my arc. Keep my radius as R. Allison, what about my angle? 36 degrees. So where do I fill that in? Be careful, I don't want you to fill that one in. Because, you want to help her out, why can't we just fill in the 36? It needs to be in radians. Okay? It's got to be changed to radians. So multiply by pi, divide by 180. Okay, and 36 will go into 180 exactly 5 times. Okay, so our angle in this case is pi over 5. Now we can fill that in. All right, so we want to get r by itself, and we want to get the pi and the 5 on the other side. Does anyone know how you can get both of these on the other side at the same time? Yeah, what do you do with the reciprocal? Multiply, divide, multiply. Okay, multiply both sides by the reciprocal. If you do that, cancels out the 5s, cancels out the pi, and you're done. So the radius is 5 times 13, which is 65. Yeah, 65 over pi. Okay, what kind of label do I need on that? Feet. Radius is a length. Our lengths in this problem were feet. Okay, so any questions on using that formula? S equals r theta. 65 over pi. If on the test they ask for the decimal, just type it in. It's about 20.69 feet. All right, so any questions on that formula? All right, make sure you have that one for test tomorrow. Okay. Last formula we're going to look at is area of a sector. So, area of a sector, okay, a little bit different. Instead of finding the length of an arc, okay, we're going to start out with same kind of picture. We're basically going to find the area of this region in here. You can kind of think of a sector as shaped like a piece of pizza. Right? It's got two edges that are straight. It's got one curved edge on the top. And this formula, this is really going to help you for tonight. Right? So what's happening tonight? Besides homework, after homework. Yeah. Reference, yeah, you can make a reference sheet. This isn't school related. Something else is happening tonight. The Patriots game, right? You gotta watch the Patriots game. So what's a common food you might get at a football game? Nachos. You got nachos, pizza. There we go, pizza. So what I'm trying to help you do is figure out the area of a slice of pizza, so you can go into the store and get the best value for your money. I'm trying to help you guys out. All right, so basically think of it that way. An area, a sector, it's like a piece of pizza. That's what I'm trying to get you to remember. Shaped just like a piece of pizza. All right, I've done pretty much the same diagram we had last time. We got theta 1. There's theta 1. Okay, our area is this big spot right here, and this other spot in here is, call it area 1. Now, what do you think would happen if you take the size of this angle and double it? What do you think would happen to the area?
It would double.
It would double. Okay, if you make the angle twice as big, you make the area twice as big. Okay, make the angle half as big, make the area half as big. So again, these are directly proportional. So we're going to be able to set up another proportion. Okay, the only problem is we need that starting fact. Okay, in 1 foot is 12 inches. 1 minute, 60 seconds. We got to have something to start with, or we can't do anything. Right. So this time we're going to suppose theta 1 is something, but it's not 1 radian. That won't work this time. Okay. Anybody know what we could let theta 1 be, and we would automatically know the area? Think about theta 1 getting really big. Yeah?
360 degrees.
Exactly. Okay? 360 degrees or 2 pi radians. If you let this angle get so big that it takes up the whole circle, now we don't even have a sector. We've got the area of the entire circle. All right? So if you're confused, kind of think of it this way. Okay? Here's a 90-degree angle. All right? Here's letting the angle get a little bigger. Okay? 180. Okay, eventually, if we let it get big enough, okay, it's eventually the area is going to take up the whole thing. Okay? And to make it take up the whole thing, the angle has to be 360. So if the angle takes up the whole thing, we know we've got a circle, not just a sector. What would that make area 1? What's the formula for the area of a circle? Anybody remember what number is usually involved anytime we've got circles?
Pi.
Yeah, so we got pi in there.
I think it's 2 pi radius.
Okay, 2 pi radius, that's good. That's for the circumference. But we did use that yesterday.
So there's just 2 pi.
No 2.
Oh, x squared, j,
I think a couple people said it.
pi squared.
Pi r squared. Okay. Here's your starting fact. This is like in 1 foot, there's 12 inches. In 2 pi radians, that's the area. There's our starting fact. So let's set up our proportion. Okay. Theta 1 compared to area 1 is directly proportional to theta compared to the area. Okay, so theta 1 is to area 1 as theta is to area. There's our proportion. And now fill in those two things. Okay, theta 1 is 2 pi. Area 1 is pi r squared. Okay, that's kind of the starting fact that we can use to figure out other things. Theta and area, we don't know. We just leave those blank. Okay, and we just did this before to solve a proportion. What's that technique we use? Good, we're going to cross multiply. But before I do that, is there anything I can cancel out here? Yeah, we got the same thing in the top and the bottom. Pi and pi. All right, so let's write out what we have. We have 2 times a equals, what's on the other side? Good. Radius squared times theta. Okay, now I want to get a by itself. So what would I do? Yep, we divide by 2. So we get area equals r squared theta over 2. Or dividing something by 2 is the same as multiplying by what? A half. Okay, that's how the book writes it. Okay, and that is the formula for how you find the area of a sector. That's the other formula from today that you need to know for the test. A equals 1/2 r squared theta. Okay. That's the area of a sector. Okay. What do you think A stands for? Yeah, A is area. Okay, R. That's my radius. Theta. That's my angle, and what do you think I got to be careful with? Yeah, it's got to be in radians. Okay, we could have come up with these formulas doing it in degrees. The only problem is they'd look a little messier. Okay, I think this one and the other one, they look pretty clean. Just 1/2 r squared theta, that's it. Okay, does everybody have this formula and what each variable represents? Okay, so we'll go through, we'll try a few of these, and that'll be it. Okay, so this problem is asking us for the area of the sector. First thing I like to do is just write down which formula I'm using. It's either S equals R theta, or A equals 1/2 r squared. In this case, it's area. Okay, Nathan, what am I going to fill in for r?
Pi over 6. Or no, it's 4.
Right. Okay, pi over 6, that's going to be my angle. Okay, so my radius is 4. And then the angle, that's pi over 6. Should I have converted something before I wrote it down? No. Why not?
It's already good.
It's already in radians. Okay. All right. How about Callie? First thing I'm going to do here, if I follow order of operations, is what? Good. I'm going to square 4, which is 16. And then if you take half of it, you get 8. So we have 8 times pi over 6, which we can reduce top and bottom by 2. 4 pi over 3, that's the area. And what should the label be on that? Okay, close. Centimeters squared. Okay, remember, you're finding an area, so it's centimeters squared. Okay, any question on if I give you radius and an angle and ask you to find area, how you do it? So everyone's okay with this one? Okay. Why don't you see if you can set this one up on your own? Okay, try to set it up. You're going to be solving for the radius. Eventually, to get r by itself, what are you going to have to do at the very end to get rid of an exponent of 2? You're going to have a square root somewhere. Okay, so at the very end, you're going to end up taking a square root. Okay, but just try to see if you can set it up, and then we'll go through it together. Let's take a look at it. Just make sure we can at least get the right numbers in the right spot. Okay, so that's important. Oh, Brandon, can you tell me what you had as an equation when you set it up?
8 pi over 3 equals 1/2 r squared times pi over 4.
Perfect. Okay, how many people had pi over 4 for the angle? Yep, that's exactly what you should have. So he converted it. That's good. Put everything in the right spot. All right, so now our goal is to get r squared by itself. What's one thing I could do to try to start to move some of this stuff to the other side? Yeah, I could times each side by something.
Wouldn't it be 4 over pi?
Yep, you could start with that. Multiply each side by 4 over pi and 4 over pi. And you're going to get a lot of stuff that cancels out. 4's are gone. Pi's gone. Okay, now on the right-hand side, you just have 1/2 r squared. What about on the left? What's going to happen there? Yep, pi's cancel out. And I'm left with 4 times 8 is 32 over 3. Okay, so that made the equation a little bit simpler. Hannah, do you see what I could do next to get rid of this 1/2?
Multiply by the reciprocal.
Yep, which would be
2 over 1.
perfect. Multiply each side by 2. Multiply by 2, or 2 over 1 if you want. It's going to cancel that. Now I've got 64 divided by 3 on the left. Got r squared on the right. Jacob, what am I going to do now? Do you remember what the opposite of squaring something is?
Square root.
Square root. Yep. So what we're going to do is take the square root on both sides. And when you take the square root of a fraction, the way you do it, take the square root of the top and the bottom separate. So that's gone. And I get r equals,
8 over the square root
yep, I'm going to get square root of 64 is 8 over the square root of 3. Okay, there's only one problem with that. Does anybody know what the problem is with that as a final answer? Yep,
Can I have square root as a denominator?
right. You're not allowed to have a square root as a denominator. Okay, so there's something you can multiply the top and the bottom by. Same thing. That'll cancel the square root out of the bottom. It might move it to the top, but that's fine.
just
The square root of 3 over the square root of 3. Okay. And what that's going to do is in the top, it gives you 8 times the square root of 3. In the bottom, you have the square root of 3 times the square root of 3. That's the square root of 9, or what? 3. Okay, so there's my radius. So that last step is something we haven't talked about yet, but it could come up. Okay, and my label on this one was, let's go back up, inches. Yeah, this time it's the radius, so it's just inches. Okay, so any questions on that one? That's the hardest one, finding the radius, because you've got to do all the square root stuff. All right, and last one. This time, I'm going to give you the radius, so that's going to make it a little bit easier. Giving you the area, I want to know the angle. Okay, Paige, can you just remind me, what's my formula for area?
Half radius squared.
Yep, 1/2
Theta.
radius squared theta. Perfect. Okay, this time I've really laid it out which variable is which, so fill in pi over 2 for the area. Fill in 3 for the radius. And leave the angle as theta. Okay, Alex, what's 3 squared? 9. So I've got pi over 2. And then half of 9, I can just write it this way. Don't even have to worry about the decimal. And I'm at my last step. Zach, what's my last step to get theta by itself?
You need to multiply by the reciprocal.
Good, which is?
9 over 2.
So the original is 9 over 2.
Oh, I mean 2 over 9.
2 over 9. Good. That's all gone. And 2 over 9. And then that's gone. Okay, so what's my final answer? What am I left with?
Pi over 9.
Pi over 9. Okay, that's in radians, so I don't need a label. Any questions on that one? All right, so in the homework tonight, they're going to give you 2 problems. One of them is going to be about a clock. One of them is going to be about a pendulum. Okay? And they might say something like, when the minute hand is pointing at 12, and then when it's pointing at the 5, find how far the tip of the minute hand moves. What is that path that the minute hand is really making? It's an arc. Okay, so you're finding an arc. Okay, they'll tell you how long the minute hand is, which that's really like your what? That's your radius. Now the only other thing you need is your angle. Well, nice thing about a clock, everything's equally spaced. Does anybody know how many degrees between each 5 minutes on the clock?
30.
Yeah, easy way to think about it. There's 90 right there, right? So if you break that up, 30, 60, 90. So every 5 minutes, you move 30 degrees. Okay, so you can figure out your angle, and your radius is the minute hand. The other problem they're going to give you is something about a pendulum swinging back and forth. And they're going to ask you, how far does the tip of the pendulum move? What's that path that the pendulum makes? Yeah, it's another arc. And the length of the pendulum? There's your radius. Okay? So it's the same idea.
So just find that.
Yeah, they're just going to ask you to find the arc length. Okay? Some people look at the word problem, they get confused, but it's really, that's all it's asking. All right? So I'm just trying to give you a couple hints on the homework. Okay, so the homework, same section as last night, page 99. 71 to 87 odd, and 91 to 94 all. So tomorrow we'll have our test on section 1.1 and 2.1. Okay, we'll deal with the summer reading after that. And don't forget, I'll be after school today if anybody needs extra help.